Good? Okay, so this is a brief introduction to safety on the metal lathe. A metal lathe has a bunch of different parts, but it's still a machine tool. As a result, you should always have protective eyewear. When you're working here, you should have an apron that encloses most of your clothes, and make sure that things that dangle out don't hang out, like keys, hairbands and things like that. On your hands, if you tend to wear rings like I do, take your ring off, because the ring can get caught inside some sharp bits and just do some damage to you. And another thing is make sure that you have some enclosed leather shoes and that the floor is clear of any obstructions. Now the lathe should be basically fairly well clear of any other project pieces. It should be reasonably swept down, so most of the swarf should be absent from here. When you start, just have a look at it and make sure that it looks placed. The guards, these are the guards. This is a pulley guard. If I lift it up here, you can see there's step cone pulleys. The step cone pulleys are designed to adjust the speed of the lathe. If you need to adjust the speed, and that may need to happen, then you'll see on the right here, there is a lever. When you lower that lever down, it's a cam system and it loosens the belt up, the belt tension, and you can change the belt from one pulley to another. So at the moment, the lever will go in the up position, and you can see here, this is the motor down the back of the lathe. It's driving this spindle, and this becomes a drive pulley, that becomes a driven pulley, so it's on its fastest speed setting at this point in time. So that's one guard that has to be in place before you use the lathe. The second guard is at the back over here. And maybe if I just show you on this other lathe, you'll be able to see more clearly. So this lathe here, this has a pulley guard system. So it's a secondary pulley that takes from the motor up to the spindle at the top here. Make sure that that guard's in place as well. Just for your information while we're looking over here, the back of the lathe here has two levers. This lever over here you won't need to touch a lot. That engages changes the direction of the spinning of the shaft, so it can go from forward into reverse. You won't need to worry about that so much. And over here as well, there's some direction changing which engages a lead screw, which is this big screw that you see that goes along the bottom of the lathe. So that large screw, maybe you want to pan out a little bit backwards. That large screw runs the whole length of the lathe. It's called a lead screw. And the lead screw, by pushing down this lever over here, you engage a set of split nuts that causes the carriage, and this is called the carriage, to automatically travel down the lathe powered by the lead screw. You can change the direction to make the carriage travel backwards if you change this gear system here that I'm holding over there. But mostly you won't need to worry about that. That's just the name of some of the parts. Okay, so back onto this lathe over here, some more names about parts. We've spoken about guards being in place. This is the chuck of the lathe. The chuck has 3 jaws on it. It's called a 3-jaw chuck. There are other sorts of chucks. For example, this one over here, which is a 4-jaw chuck. You can see it has 4 different jaws. On this, all the jaws of the chuck are operated independently, which means that you could hold a square section in here and adjust it to be in the middle. Whereas on a 3-jaw chuck, when you loosen and tighten the screws on the chuck using this key, all 3 are loosened and tightened at the same time, very much like a drill press. So you can see as I loosen up here, all 3 jaws are loosening, and if I tighten, all 3 will tighten at the same time. So for round stock or round workpieces, 3-jaw chuck's probably a good system. But if you have irregularly shaped workpieces, you can use a 4-jaw chuck. Now when you tighten, make sure you tighten firmly, rotate by hand, tighten up the next jaw and tighten the 3rd jaw. So all 3 should be tightened firmly. The workpiece shouldn't be protruding too far from the jaws of the chuck if it's not supported. There are ways of supporting the workpiece, but at this point in time it should remain close to the end of the chuck, because if we apply pressure with a tool bit and it causes it to bend when it's spinning, then the immovable will hit the unbreakable and the unthinkable happens. So let's just make sure that there's not too much poking out. Okay, now next thing to be aware of is that as I mentioned before here, that this is called the carriage of the lathe, and this is your main wheel, your main carriage wheel. By winding it backwards and forwards, it moves the tool bit to and from on the same axis as the ways of the lathe. These are called the ways, these triangular shaped section. The carriage rests on the ways. Above the carriage is a smaller lever here, which operates a slide called the crossfeed slide, because it slides backwards and forwards and moves the tool across the face of your project. So you wind those just like I'm doing with my finger. Now you'll notice that each of them, if you look carefully, there's an actual guide system down on here. And these markings correspond to very fine adjustments. So it's a precision tool, and you can arrange, I think, up to a couple of hundredths of a millimetre in terms of accuracy. So it's a very accurate bit of machinery. Above the crossfeed slide is the compound slide. This is called the compound slide because it can be moved by loosening these screws from side to side on an angle. So it can move like this, and that gives you a feed which can cause you to be able to machine it at precise angles. And if you look, my cameraman goes nice and close over there, you'll be able to see some fine graduations if it comes into focus about here. You're not quite there. All right. But when you come into real life in the lathe, just along here, there's some very fine graduations where you can notice the degrees down to a single degree. So that's called the compound slide. And when you've finished setting it to where you want, you need to tighten up these set screws, and the compound slide will stay in position and operate well for you. All right. Now, compound slide, crossfeed slide, carriage, main hand feed lever. This is the forward and reverse for the lead screw feed. This is called the tailstock. So the back of the lathe over here is called the tailstock. The tailstock has a lever as well, and you notice it pushes out this fixture over here. And again, there's a graduation, so you can easily check and see if you want to drill to a certain depth. You can drill exactly to the depth that you want. This is a locking lever over here, which bites onto this shaft, causing it so that you can't move. If you want to be in a fixed position, you can lock it into place with that lever. If you just step back a little bit, pan it back a little bit that way, this arm over here locks and unlocks the tailstock. Pushing it down, it means the tailstock can slide along the bed of the lathe, and pushing it up like that, it locks into position. So the ways are sitting on top of the bed. The whole long section down here is called the bed of the lathe. Alright, over here in front of the tailstock is the centre. It's called the centre of the lathe. This one here is called a live centre, and I'll wind back this hand feed lever the full direction, full way, and I'll take it out and show you. So it's called a centre because it has an angle face over here, and it's a live centre because it has a bearing surface inside it here. And this is the object that you'll use to give support to a workpiece that's projecting a long way out of the chuck that you still want to machine. So for argument's sake, if I had a piece of work that was quite long, I'll move this hand feed lever back, say it was as long as this, and it was sitting inside the chuck, I'd need to support one end. And I'd use a specially made hole, which I could drill using this drill over here, which is called a centre drill. It would create a surface, an angle surface, that would fit exactly inside that live centre and support one end of my workpiece, so it wouldn't start to bend as I machined it. So that's the idea of the live centre. And as I've shown you over here, this is just a normal Jacob's chuck, just like you'd use on a drill press. That's got a Morse taper, which is an angled surface that can sit inside here, and if we wanted to, we can drill holes using a Jacob's chuck into the workpiece. So as the workpiece spins, you can see it over here, as it spins, I can then advance the tailstock into the workpiece, wind it forward using the hand feed lever, and that'll effectively drill a hole. But unlike the drill press, the Jacob chuck's not spinning, it's the workpiece that's spinning instead. That's how you drill. Alright, now let's suppose we want to machine something. I have to make sure that my tool piece, which is this object over here, should be exactly on centre, which means that it should be really sitting just in the middle and the centre of that workpiece there. If it's not, when I machine across the face, it'll leave a little indent, a little raising section called a nipple. That's it over there. Yes, most students laugh when we talk about them. So, I'm going to do what's called a facing cut, which is I'm going to start the lathe and I'm going to machine across the face to get myself a nice perpendicular edge. And that's what you'd often do with a bit of new material. So to do that, I'm going to be aware of, if you just pan back a little bit, there's the on-off switch down the bottom over here, and it conveniently positions near your knee. The off switch is able to be turned off with your knee, just like the drill press. Now before I start the chuck, I should rotate it once or twice by hand to make sure nothing's in the way. And once it's ready to start, I'm ready to turn on the machine. Chuck's now spinning. I now need to advance the tool piece close to where the object's spinning, and carefully, so I'm using two hands on the wheel. Now I'm going to use the crossfeed slide to wind across, and you can see the schwarf coming off. I'm going to wind across and make sure, see if this tool piece is centered. That is to say, to see if it cuts all the way across without leaving a nipple. So let's find out. If it's not, and it does leave a nipple, I'm going to have to adjust the height of the tool piece. And it looks like I will have to adjust that height. No, there it is, spot on, no nipple at all. So the tool piece is perfectly adjusted. So you saw how I used the hand feed levers gently, not too quickly, and you shouldn't hear any loud squeaking sounds. Loud squeaking sounds indicate rubbing and friction, so it means that the torque piece might be blunt or the angle at which it's set is not correct. So it should be a nice smooth system like that, and you should be left with a lovely nice shiny finish. Very satisfying, very therapeutic. Do it when you want to relax. Done. Winding back out of the way, and I'll turn off using my knee on the stop switch, and we've just completed our first operation. So if you want to look closely there, you can see that it's nice smooth surface, it's been machined, and there's no nipple poking out. So that's a successful job. Now, just to illustrate to you while we're here, and I've got the cameraman operating well, I'm going to show you how to drill a support hole. So we're going to use this Jacob's chuck with that odd shaped centre drill that you see. Place it inside. Wind forward on the tailstock a little bit so the Morse taper will bite in. Then I'm going to move my tool bit out of the way because I'm not going to use this right at the moment. I'm actually going to use the drill. So I'm going to bring the tailstock forward, release the locking lever, which I've just done here. Bring the tailstock forward so it's close to my project. Then I'm going to lock the tail piece in position there. And I'm going to leave this loose because I want this shaft to wind backwards and forwards. Test it once by hand, nothing's in the way. Start the machine, and then using the hand feed lever at the back here, I'm going to wind the drill bit into the project, and you'll see as it goes in over there, it will start to create a hole exactly the shape of the drill bit, which is designed to fit inside a live centre. So I've just finished that now. I'll wind the drill bit out, and you can see it's made that oval sort of shaped hole. So now I'll turn the machine off, move my tailstock out of the way, and I'll show you what I mean by supporting the work when you want to do a long cut. I'm going to release the project, wind it out a lot further than I would normally do. Always take the chuck key out of the chucks, so don't be confused into leaving it sit there. Very easy for that to spin if you forget that it's there and hit you in the face. I'm now going to change across. Instead of using this drilling chuck, I'm going to use a live centre. There it is there. Doesn't have a drill bit on it. Put it in position, move it forward, and you can see it mates perfectly into that location. I'll wind it out. It's designed to fit exactly in there. I'm going to push a little bit forward to give it a bit of a bite, then I'm going to lock the tailstock in position. So now, when I tighten up the jaws of my chuck here, I can machine on an angle if I should choose, and do a transverse cut. Now, I should check to see if this is on centre, and these older machines like this often will lose their centre as you spin them around. But if I'm very careful and keep the thing exactly in the right position, I may be able to keep it exactly on centre. And let's find out if I've been able to do that. And I'll show you what a transverse cut will look like. I'll use the cross feed slide to do that. Check first with my hand, everything's good. Wind in, and it's cutting quite well, as you can see. So I'm winding the main hand feed lever now with my hands, and you can see as I'm winding across, that black scale from the milling surface and the rolling surface is now disappearing, and what you see is the bright, shiny, lustrous metal underneath as I'm winding along. Now I'm doing this by hand. If I wanted to, I ought to be able to engage this lever down here. I think I should be able to do it like that. That's going forward or backwards? Yeah, okay. Now, I'll go through that process again. I've just moved this gear lever down one little notch, so it's in the bottom notch. I've now engaged the lead screw. So whilst the lead screw, you watch it as I turn on. See how the lead screw is moving now? When that gear wasn't engaged, that lead screw was stationary. Now if I put the locking nuts in, the carriage will automatically travel across. So if you focus on there, you'll see that my hands are not touching anything. It's automatically travelling across at a speed set by the lead screw. That can save me a lot of time, but I have to be very careful and make sure I don't forget. Otherwise, once again, the immovable will hit the unstoppable and the unthinkable. So I'm going to stop that now by flicking the lever. I just wanted to show you that and stop the process. And that would cover almost all of the aspects of safety on the lathe. Just remember, never leave the machine running while it's unattended. Please be aware that you should only be one person operating the machine at any one time. The schwarf, when it comes off, will be hot, and sometimes it'll actually be quite sharp as well. So try not to pick it up with your hands the way I'm showing you. You should instead use a dustpan and broom to sweep it away. Be careful when you're machining. Don't keep your head too close to the project, so no looking at it like this, because it's likely that other bits of hair or hot bits of metal will come off and they can hurt you quite badly really, not quite well. So that will just about conclude the demonstration on the lathe. I think I covered everything. Happy and safe lathing. Bye.